Imagine waking up to a misty, shivering morning in Kabale, and then instantly stepping into the harsh, blinding sun of a Karamoja afternoon. The air around you feels completely different. We sense that difference instantly. It's the same instinct a parent uses when they press a hand to a baby's forehead to check for a fever. Our skin easily tells us if something feels hot or cold. But our skin can actually trick us. Imagine placing 3 bowls of water on a table, one cold, one hot, and one right in the middle at room temperature. If you put your left hand in the cold bowl and your right hand in the hot bowl for a minute, and then quickly dip both hands into the middle bowl, something strange happens. Your left hand will tell your brain the water is warm, while your right hand screams that it's cold. Because the brain receives contradictory signals from each hand, you can't trust your own touch. Your hands are in the exact same water, but your brain receives completely opposite messages. Our skin is designed to feel sudden changes in our environment, not exact measurements. To find out precisely how hot or cold something is, we need an objective tool. That tool is the thermometer. It works based on a very reliable rule of nature. When liquids get warmer, they take up more space. They expand. Inside a very narrow glass tube, that expanding liquid has nowhere to go but straight up. This image shows a clinical thermometer used by nurses. Notice how the numbers only range from 35 to 42 degrees Celsius. It only covers this specific range because the human body cannot survive if it gets much colder or hotter. The liquid inside matters too. Some use mercury, which is shiny and handles high heat, but is highly poisonous if the glass breaks. Others use colored alcohol, which is cheap and safe, though it boils far too easily for some laboratory tasks. You might wonder why we don't simply use water. Water does the opposite of what we want. As it gets close to freezing, it expands instead of shrinking. It's also completely clear, making it hard to read, and it leaves wet streaks clinging to the inside of the glass. By pairing the right expanding liquid with a properly shaped glass tube, we create a device that responds perfectly. It gives us a reliable number every time, bypassing the flaws of human touch. To use a thermometer correctly, we have to clear up a common mix-up between 2 distinct ideas: temperature and heat. Imagine a massive saucepan of water boiling to make pasho, sitting next to a tiny cup of water boiling for tea. Thermometers in the boiling pot and cup both reach exactly 100 degrees Celsius. They share the same temperature. Heat, however, is total energy. The massive pot holds vastly more joules. Similarly, a matchstick has high temperature, but a vast lake holds immensely more heat. Our thermometer strictly cares about the level of hotness. It ignores the overall size of the pot, lake, or cup, and tells us the temperature. But a glass tube filled with liquid isn't useful until it has numbers. If you build a completely blank thermometer, how do you determine exactly where to draw the lines for 0 and 100? Place the bulb in pure melting ice. When the liquid settles, draw a line for 0. Next, suspend it in pure steam. Once the liquid peaks, mark it 100. Finally, divide the space into 100 equal increments. Each mark is 1 degree Celsius. Because pure water behaves the exact same way no matter where you are in the world, anyone can follow these steps. It turns an empty glass tube into a precise, universal scientific instrument. We have moved from relying on the confusing signals of our skin to reading carefully calibrated marks on a glass tube. This tool helps us understand our environment. In places like Uganda, the atmospheric temperature changes constantly based on cloud cover, wind, and altitude. Even near the equator, the highest elevations experience freezing, snow-covered conditions. Down at lower altitudes, tracking the intense daytime heat is a matter of livelihood. Farmers rely on these exact high temperatures to dry coffee beans and maize, using the sun's powerful energy to process and preserve their crops. When the sun sets, the temperature drops rapidly. This nighttime cooling is just as important, causing moisture in the air to condense into dew, naturally watering those same plants while we sleep. Understanding temperature is a practical skill for life. It is the key to understanding the invisible energy flows that dictate our weather, secure our food supply, and protect our health.